Finding a linear function. First, let's recall that a linear function is the same as a linear equation, it's just expressed in a different language. So when we're asked to find a linear function, the first thing we should start thinking is, let's just find an equation first. And then at the very last step, I can change the language so that I have a function instead of just an equation. I'm given two ordered pairs in function language, because remember we're following the model f of x equals y, and so each of these statements gives us an x and a y. I can just call this x1, y1, x2, and y2. Once I recognize this, I'm now in the situation where I just want to think about the formulas that I have for equations of lines. We have slope-intercept and point-slope form to make the equation. Both of those require a slope, so let's first find the slope using our slope formula. M equals the difference in the y's, or y2 minus y1, over the difference in the x's, or x2 minus x1. So that's going to be 7 minus -3 divided by 4 minus 2. Of course, the minus and -3 becomes plus. So this becomes 10 divided by 2, which is 5. We end up with the slope is 5. After we've found the slope, we're ready to find the equation. And since we don't know the y-intercept of our line, one of these points would be the y-intercept if it had x-coordinate 0, but neither of these x values is 0, so we don't know the y-intercept. We have to use the point-slope form of a line. Y minus y1 is equal to m times x minus x1. And into this formula I am going to plug the 5 that I found from the first step in for m. And I'll use the point x1, y1 and just kind of throw out the point x2, y2 for now. We used it to find the slope, but we only need one point at this stage to find the equation. So -3 for y1 and +2 for x1. It doesn't really matter which of these 2 points you use, but I find that it's often easiest to just stick with the ones that we already defined with the right label. So this becomes y plus 3 equals 5 times x minus 2. Distributing into those parentheses then gives us y plus 3 equals 5x minus 10, and then subtracting 3 from both sides gives us y equals 5x minus 13. There's just one step remaining here. As we mentioned, we need a function, so now is where we go back from equation to function by replacing our y with f of x. So that our final answer is just f of x equals 5x minus 13. So whenever it's helpful, we can go back and forth between function and equation language if it helps us to achieve our goal. We're next asked what is f of 5. We're going to take the function that we just found and plug in 5 for x, right? So f of 5 is equal to 5 times 5 minus 13, which is 25 minus 13, or 12. So our answer here would just be the number 12. Onto an application of straight line depreciation. Suppose that a new computer is purchased for $1,800 and it is worth nothing after 4 years. We're going to find a function that expresses the value v of the computer as a function of its age. So that means the value of the computer is going to be our function or our output, so that will be our y variable, and the age is going to be the input, so that would be our x variable. Again, we're going to do everything in the language of equation and then change it into a function when we're done. Y equals mx plus b is a reasonable formula to use here because it turns out we do know the y-intercept this time. If we look at the information that we're given, new, just that word new tells us that the age is 0. So this is an ordered pair x equals 0 and y equals 1800. 0, 1800 is one ordered pair that we're given. And after 4 years, so this is another value of x equals 4, the computer will be worth nothing. Nothing in this case means that y is equal to 0. So essentially we're given the two intercepts in this problem. Looking at these ordered pairs again, this says at 0 years of age, the computer is worth $1,800, and at 4 years of age, the computer is worth $0. That's how I have interpreted this information as two ordered pairs. So to find my slope, I can just plug into the slope formula. M is equal to 0 minus 1800 over 4 minus 0, which is negative 1800 over 4, which turns out to be negative 450. So this is what I'm going to plug in for my m, and as I already noted, we do know the y-intercept in this case. This point here is the y-intercept, and we can tell because it has x-coordinate 0. Anytime the x-coordinate is 0, we know that that point has to lie on the y-axis, and therefore it is the y-intercept of the graph. So for my b, I'm going to put 1800. And for my final answer, I want this to be the function v, so I'll call this v of x instead of y. So v of x equals negative 450x plus 1800. In order to graph this, a lot of the work here is defining a reasonable scale. I know that I want to plot these two intercepts. I don't really even have to focus on the equation. I can just use these 2 points here to graph the function. So I know that I want to be able to get up to 1800 on my y-axis. I need to define a scale that's going to allow me to get up to 1800, but that is going to use as much of this y-axis as possible. So it seems reasonable to go up to 1005 ticks and then up to 2005 more ticks. So that's saying each tick mark is worth 200. We could put a few more labels in here if we want to, but it's not really necessary. We have defined our scale. It goes 2, 4, 6, 8, 1000, 12, 14, 16, 18, 2000. Now we need to define the scale on the x-axis as well that will allow us to use as much of the grid as possible and still get out to 4. So I'm going to say 2 tick marks is 1 unit down here. 1, 2, 3, and 4. And we'll go ahead and label 5 as well. And all we have to do at this point is plot the 2 points that were given. 0, 1800 is here on the y-axis. 4, 0 is down here on the x-axis. And we can draw the line that connects these 2 points. We don't want to extend this line out of the graph at this time because it doesn't really apply beyond the first quadrant. If we go into the second quadrant over here, that's suggesting years before purchasing the computer, and if we go down here into the fourth quadrant, then that's just representing when the computer is worth negative values. So it seems reasonable that only the part that lies in the first quadrant should apply. And that's what we want to think about also when we answer this question about the implied domain. For the very same reasons, we're only going to consider this model while the computer is worth more than $0. So that would be from 0 to 4. What's the value of the computer after the first year? We could use the graph or the formula to estimate this. Since the graph is right here, it seems like it's easier, and this would be 1,400. So let's say $1,400. And finally, when will the book value of the computer be $450? Let's try to find 450 on here. It looks like it goes 200, 400, so 450. Let's see, this will be 500, 450 would be about halfway in between. We can trace over to the graph, and it looks like that's right at 3 years.